following the lab activity of the reaction of magnesium and oxygen, well, the oxygen part of the air, we're going to use the reaction as a review of topics you've already studied. So, for example, the periodic table, formulas, equation, types of reactions, redox, bonding, crystal structure, and the observation part of the lab. So the first one, we're going to look at elements in the periodic table. And so materials are either going to be elements, mixtures, or compounds. And what makes magnesium and oxygen as elements? And those are our reactants. And then we form a compound from the reaction and describe what that is like and why the compound formed. It's made of elements, but it is not an element itself. And where do magnesium and oxygen appear in the periodic table, and how does the position in the periodic table let us know more about the properties of those elements? And we have one in the left-hand column, which we can call the S block, and one towards the right, and that would be in a P block. And we can put the stepped line, the zigzag line, and that is going to separate the metals from the non-metals. So we know magnesium is going to be a metal, oxygen is going to be a non-metal. It also is going to tell us about their electron arrangement, and we have magnesium as 2, 8, 2, so it's in the third row. The first two rows are full, 2 and 8, and 2 in the final one. So the outer shell, 2 valence electrons, and for oxygen it's 2, 6, with 6 valence electrons, which we can do the more complicated electron configuration for magnesium and give the neon, and then we've got 3s2 electrons for magnesium's valence shell. And for oxygen, we've got 1s2, 2s2, 2p4, or if we're looking at the valence shell, helium as the inner full electron configuration shells, and the valence shell 2s2, 2p4. And if we're writing formulas, here we've got 2 elements, and so we've got several examples here. And if we write the formulas, we can actually look at this little chart. Start at the top left. Is the first element a metal? Yes. Is there a Roman numeral in the name? No. So you're just going to write the symbol and indeed its charge. And if we want the second part of the formula, the second name, and is there one other element and it ends in "ide"? Yes. Is the second element a non-metal? Yes. Is there a prefix? No. So we're just going to end in "ide", and we want the charge on the ion, which will be O2 minus, to balance with the Mg2 plus. And we need the formulas if we're going to write equations. So obviously we've got reactants on the left-hand side and products, and we name them. So first step, the word equation with the names of the chemicals involved. Then we write the symbols. And don't forget that oxygen is diatomic. And I'm not worried about any balancing at this stage. So I do not need to worry about 2 oxygens at the moment on the product side, because the formula of magnesium oxide is MgO. And we're going to use the combining powers to write the formulas Mg2 plus, O2 minus. And then we balance. We want the same number of each type of atom on either side, so we do an audit. So count each of the components. So 2 magnesium atoms, 2 oxygen atoms in O2, and 2 magnesiums and 2 oxygens in magnesium oxide. That coefficient with MgO multiplies each of the atoms after it by 2. So we've got types of reactions here. We've got synthesis, decomposition, single replacement, double replacement, and redox, which includes combustion. And we've got the ways of just looking at A's and B's and A's and B's and C's reacting, except for combustion. I've got carbon and oxygen there for the redox reaction. And we've got a synthesis reaction, an A and a B, 2 components giving me a single compound at the end. Here we've got 2 elements. And if we're going to look at redox, remind ourselves that oxidation is a chemical reaction which involves addition of oxygen, removal of hydrogen, removal of electrons from a chemical, increase in oxidation number, and reduction is the opposite of each of those. And so I kind of remember what happens to the hydrogen happens to the electrons, the removal of, and the oxidation number and the addition of oxygen helps me remember those. But not all of those criteria have to occur. So in our reaction that we're looking at, there's no hydrogen involved, but there is addition of oxygen, so it is a redox reaction. And if you're looking at electrons as well, the magnesium loses 2 electrons. Mg goes to Mg2 plus in magnesium oxide and 2 electrons. Those electrons are gained by oxygen. And the oxygen is the charge, the oxidation number is the charge on the magnesium ion, and we write it plus 2. The charge has to come before the number. Then we're going to look at bonding. We've got a metal and a non-metal. What type of bonding occurs between a metal and a non-metal? It's going to be ionic. And when you've got ionic bonding, you have a transfer of electrons. So go back to the electron configurations and look at the Lewis structure. 2 valence electrons on magnesium in the atom, 6 valence electrons on the oxygen. The magnesium is going to lose those valence electrons, so the penultimate shell is now the full shell, and the oxygen is going to gain 2 to get its full shell. And then these are now ions, and what are the charges on each of the ion? You've lost 2 electrons on the magnesium, so it's 2 plus, the oxygen is 2 minus. Magnesium is a cation and the oxygen ion is an anion. And we can look at it in terms of the Bohr model with the electron shells, and magnesium 2, 8, 2 and 2, 6 for oxygen, and 2 valence electrons, outer electrons of magnesium, are transferred to the valence shell of oxygen in our ionic bond. So the magnesium ion now has an electron configuration of 2, 8, full outer shell, and the oxygen ion is also 2, 8 with a full outer shell. And a reminder of the properties of ionic compounds: they're crystalline solids at room temperature. They have high melting points. They're arranged in a lattice structure, framework with adjacent oppositely charged ions making up that framework. And the ionic material doesn't conduct electricity in the solid state. If you melt the ionic compound, salt, over 800 degrees Celsius, the ions can move and it will conduct electricity. And if they're soluble, and a lot of ionic compounds are soluble in water, they do conduct electricity in solutions because the ions are able to move. And finally, observations, those detailed appearances. So 2 words to describe the colour: texture and other qualitative descriptions, sparks, flashes, sounds, if they occur. And some more review, look at the reaction between potassium and iodine and complete each of the activities as we've gone through the review for magnesium and oxygen, and do the same for potassium and iodine. So pause that and work through it. And finally, very many thanks to Washington International School and their team science.